This block diagram represents a volcanic region which has undergone a variety of geologic events. So we will start with the oldest layer, and because we know from the law of superposition that the layers at the bottom are oldest and get subsequently younger, Unit 1 down here is our oldest, and then all the way here at the top, Unit 14 is our youngest. So the first event that we have is the deposition of some sedimentary layers. So we have a fine sandstone, coarse sandstone, a thin layer of conglomerate, which was likely a riverbed of some sort, coarse sandstone, fine sandstone, an algal limestone, which could indicate a marine environment. And the fossils here can help us to date this layer, as well as give us some context on the ages of these other layers. And then we have a shale, and then it's going back into sandstone. So we're going from a marine environment likely back into a terrestrial environment. So we know because of the law of original horizontality that these layers were originally deposited horizontally. So we can tell that there was some sort of tectonic activity that caused these layers to tilt. And at some point, probably around post-tilting, we know for sure after the tilting occurred, there was more tectonic activity that caused this normal fault to occur. So after all of this happened, we have an unconformity here. Here's an angular unconformity. And this tilting occurred, and then we had a layer get deposited, which is horizontal. So this doesn't line up with this. We don't have a number 9 because our 9th unit, which may or may not have existed, has been eroded away. There's no way we can tell what was there. So we go straight from 8 to 10. And then we have, when we're getting back to our horizontal layers here, we have coarse sandstone, fine sandstone, and then a shale layer. And then intruding upon all of these layers from 1 to 12, we have a dike, an igneous intrusion here, which comes out between layers 11 and 12 as a sill. And we can tell that this dike is younger than all of these layers because it cuts through all of them. So it shows a cross-cutting relationship. And these little lines here indicate contact metamorphism. So this intrusion has altered the rock in which it has intruded and caused some metamorphism. So then continuing on, we have a layer of fine sandstone. And finally, our youngest layer is this layer here, this thin layer of pyroclastic material. So we don't know for sure if this dike is younger than these layers up here. It is possible that the dike just, when it intruded, it didn't make it past this layer of shale. The shale trapped it. But we know for sure that it's younger than these first 12 layers. So that's all we can say for sure. And then if we look over here, we have a large magma chamber, which is an active chamber leading up to these active volcanoes. And this chamber is cutting through this pyroclastic material here. So we know that this chamber is younger than this pyroclastic material, but at the same time, depending on the age of these volcanoes and how many eruptions we've had, this same chamber could also be responsible for this pyroclastic material. So that is my block diagram, and I hope you enjoyed it. Thanks.